Hello, today we're going to learn how to do fracturing in Houdini so that we can achieve a result like this after we later do a simulation using these fractured pieces. So let's jump into Houdini. And this is where we left off last time. And we had, actually before we did our RBD simulation. So this is from the signed distance field lesson. So let's continue from our signed distance field that we created using a simple vex snippet. Okay, so first of all we will make a mesh. So let's press tab and type convert and the volume. And this will create a mesh from this volume. And let me just hide the points. Okay. And let me zoom in a little bit so we see this easier. Okay, and this is quite a lot of geometry to work with. So we want to remesh this. So let's press tab and type remesh. And connect this to our convert volume. And look at this result. And this will take a little bit of time. And this is not looking very good yet. So let's press P and go to adaptive. And here, let's see, change the iterations to 3. And wait a few seconds. And now we have something decent to work with. Okay. So next we are going to fracture this, and the way we do this is using Voronoi fracturing as the first stage that will later be used in the simulation, and we will also do a more detailed fracturing that we will use for rendering. So let's start with the Voronoi fracturing. So to do this we need Voronoi points. And to keep this simple, we are going to create only 2 points. So let's press tab and type line. And we are going to create a line with only 2 points. And let's display this line. And press P to edit the parameters and change the direction to x1 and the other 0. So now we have a line, and I'm going to show the points in this menu here. Okay, so now we have a line and we want this to be centered in the middle. So I'm going to change the origin to minus 0.5 in x. And then I will change the length to perhaps 2. Or let's keep the length to 1. And let's show the mesh as a template by pressing this purple icon here. And now we can see if these points would work as centroids for our pieces. And I think this is a good starting point for doing fracturing. So what Voronoi fracturing does, it takes these points, and between each point it takes the neighbor and cut that in half and creates a plane. And if you have several points, then it will do this for all the neighbors. But we start with just one simple cut to make it simple. So let's add the Voronoi Split node. So press tab and type Voronoi Split. And this will take the geometry on the left and the points on the right. And let's see what we get now. And let's hide the points. So now, let me zoom in. I will just hide this camera because that is distracting. So let's remove that. So now I can zoom in easier. Okay. So now we can see that we have a line here in the middle that will split this up. So we can now convert this into packed primitives. So let's look first at the geometry spreadsheet and the primitives. So we don't have any name on the primitives. We don't know which primitive is which. So let's go here and let's stamp the pieces. So we get the piece number, as you can see here. So now we have piece 0 and 1. And we also want to create an internal surface. So I will create this later so you can see why that is necessary. So let's first create a packed primitive from this. So press tab and type pack. And then connect the split to the pack and see what we get. For this will require, let's see, we have one. This will require a name attribute so it knows which primitive is which. And here we have something called a piece. So we need to convert this piece number to a name. And for this I'm going to use an attribute wrangle. So press tab and type attribute wrangle. And this is, if you look inside the attribute WOP that we are usually doing, but just to keep things quicker we can use this attribute wrangle instead, because you already know how it works inside. Okay, so let's type some VEX code here. So let's say a string at name equal and sprintf, and that makes a formatted string, and the syntax is similar to the C language. So let's type here a string that we call name %d and then comma at piece and end with a semicolon. And now we should have a name. So let's go to this node and run over the primitives. So here we have name 0 for the first piece and name 1 for the second piece. And now if you go to pack, then it will be able to collect these. So all the piece 0 go to one packed primitive and the other to the other. And it will create basically 2 points that represent these two pieces. And we still have all the geometry but in a packed format. So this is more convenient to use for simulation. So let's do an exploded view. So press tab and exploded view. And then display this. And now we can see the two pieces we created. And we don't have any internal face, so we have to create that in the Voronoi Split node. So let's tick create interior surfaces. So now we have a watertight surface or a watertight mesh. But still this looks a bit ugly because the normals are not yet fixed. So let's fix the normals. So let's press tab and type normal and put this after the split. And that will make the normals look okay. You can tweak this cusp angle if it doesn't look as you like, but this is good for now. So here we have the first setup that we will later pass to the simulation. And now we want to create another setup that we can use for rendering that looks a little bit more interesting. So for this we are going to start again with this mesh and we are going to create a grid. So type tab and grid and again template the mesh using the purple button and show the grid. And then press P to edit the grid and change the plane so that it cuts the mesh. And let's make it a little smaller as well. So size 2 perhaps, or 1 is enough here, and 2 for Y. So size 1 for X and 2 for Y. And then, or rather Z and Y and Z, but anyway. And we can also move this down a little bit. So let's take the center here and try minus 0.2. And this is good for a cutting plane. And here we also want a little higher resolution. So let's first double the rows so that we have squares instead of rectangles. And we can add even more. So let's put, see how much, 200, maybe that's too much. So let's put 100 here and 50 here. And now we have small grid points. And next we want to distort this using a noise. And if you watched my previous lessons, you know how to create OpenCL code to do this, or using a VOP node. But in this lesson we will be lazy and just use a mountain node. So press tab and type mountain. And connect this after the grid. And this is perhaps too much, so press P and change the height. Maybe 0.5 is good. Okay, so we will make this to be the cut. And next we are going to cut the mesh using this plane. And I will put this on this side just for the sake of it. Okay, so to cut this we are going to use a Boolean. So press tab and type Boolean. And these are all the same Boolean node with different presets. So you use the first one so we can learn how it works. And connect our mesh into the left and the plane into the right. And press display this and press P. And we know that the mesh should be a solid and the cutting plane is actually a surface. And the result should be a shatter. So it will shatter this, which is another word for fracture. So this is now fractured. It's difficult to see, but it should be fine. And we want the pieces from the A, and A is the mesh, to be the result. Okay, so next we need to do the same thing we did on the original Voronoi. So let's see. So we want to pack this, and to do this we are going to need, so we need a name. So let's create a connectivity node. So tab and connectivity, and connect this to the Boolean and look at what we get, and go to the spreadsheet. And now we can see it created a class attribute, and we want this to actually be a primitive. So move this to the primitive and look at the primitives here. And now we have a class that is 0 or 1. And again we want a name, so I will rename the other attribute wrangle to name and copy this because it will be very similar, and connect this to our new fractured mesh. And let's edit this. So in this case the attribute is called class rather than piece. So let's add class here. Or you could use the same and change the connectivity to output piece instead, just to keep more consistent. And now let's see. Now we have a name 0 and a name 1. And this is not necessarily in the same order as this, but it is good for now. And now we can pack this again using a pack node. And connect this after the second name. And look at this result. And also use this exploded view and see what we get. And we still don't have this working. So let's see what happened. So go to the pack 2 and the geometry spreadsheet. And you can see we have only one packed piece, so we need 2 pieces. So let's look into the pack by pressing P, and we need to enable the name attribute. And now we have 2 primitives, so 2 pieces. And go to the scene view, and you can see now we have a nice fracture. But still these normals are not that good. So let's fix this in the same way. So let's just add a normal node again. So press tab and type normal. And put this after, that should be after the Boolean to be consistent. So I put this here, and then I will align these so you can see how they are corresponding to each other. So now this normal node will fix these normal issues. So now we have a nice fracture here. And you can adjust this using the mountain node here. But let's just use this for now. So now we have one version to use for the simulation and one version to use for the rendering. And in the next lesson, we will look at taking this into a bullet sim and see how it works when we simulate this. So I hope this was helpful, and see you next time. Over and out.